Hello, welcome to the first video in a series of videos that is going to be called Tensorflow for Natural Language Processing. I'm Nate. I've noticed that the community on YouTube has not posted a lot of videos on natural language processing in Tensorflow, so I'm going to start making these videos to kind of fill a gap that we're seeing. And it'll also help people like me that are trying to learn this stuff on their own, and YouTube usually helps a lot. So let's just jump right into it. I pulled open this website here. I'm going to put it in the description. And what we're going to use is Amazon product data. So I don't want to use one of the data sets that everybody's using. I want to make sure that you guys know how to do this stuff on your own data. So I'm going to do this on two different data sets. Let's just grab this one here, clothing, shoes, and jewelry, and also sports and outdoors. So let's download these. It should only take a second. And while we wait, let's take a look at, oh, that's not what I wanted. Let's take a look at what we're going to be needing. Okay, so if you want to follow along, you got to make sure you have these libraries installed. So most importantly, you're going to need TensorFlow. So import TensorFlow as TF. We're going to need NumPy. Import pandas as well. We're going to be using tflearn just for one of their little data helper libraries. And we're going to also use scikit-learn's train test split. So import that. So if you're up to date on all these libraries, you should be good. And I'm also going to throw one in the description that you can download. You can put it in the same directory as the project file that we're making. And by now, these things should be done. Yes. So let's go in here. So you can see that we have these two files that are downloaded, and they're just zipped files. So we're going to go ahead and extract them here. So now we're going to have these two files, and they both contain JSON data. So we're going to need to handle that, and that's what we're using pandas for. So we're going to start by pre-processing the data, and this is probably the hardest part, and this might have to be a video all on its own. So let's just get right into this. And remember, we're going to use pandas, and pandas handles JSON data really easily. So read in JSON data. We're going to say df clothing. If you haven't used pandas before, then you should really check it out. And we have to pass this parameter lines equal true because it has, I think it's because there's multiple columns. I don't know, I was running into some problems with it without having that parameter, and so I threw it in there and it started working. And we're going to do this again, and I think this time I'm going to just grab it from here. It'll be a little easier instead of typing it out. And then what we're going to do is we're just going to take these and we're just going to concatenate them on top of each other. So this will give us both data frames stacked. So df equals pd.concat, and then we just throw out a list of the data frames that we want to use. Okay, now we only want the text from this, so let's run this. Make sure that it works. If we call this function here, then we'll be able to see the first few lines of the data frame, and it looked like it did work. But all we really want is this review text because we're analyzing text, right? So what we're going to do is we're going to say text equals tf review text dot values. And what this will do is it'll take what's in review text and make it into a list. And then we're going to delete the df because that'll reduce some memory. Not much, but it will. So this data helper library that I threw in here is really just this one function that I got off of GitHub. I've been using it in a few of my projects. And all it does is it will clean the string using regex. So I figured as opposed to us writing out all these regexes, I just give it to you. It's a little easier. So we're going to call to that file, and we're going to call this clean string on all of our strings. So in order to do that, we're going to say text equals data helper, which we imported up here, and it's going to be dot clean string, and then we're going to pass it a cent for every cent in our text. So that will clean our strings. Okay, so now that we've got our text into different sentences, it's going to look something like this one up here, where we got a list of sentences. Could be great stuff. I love this product. Blah 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 blah. So we have a lot more than that, but just for the sake of example, that's what it looks like. And we want to be able to turn that into indices. So these numbers are going to relate to the unique words in each sentence. So we can see that great stuff are unique words. So we assign them 1, 2, and then I love this product 3, 4, 5, 6. But in the third one, we see that we have a couple words that we reuse, I and this. So 3 is reused, and also the 5 is reused. So we're going to do this to our entire list of sentences, and we're going to end up with these unique numbers here, and the amount that we have is going to be the size of our vocabulary. So I suppose the next question you want to ask is, what exactly are we going to do with this data? We are going to be following the skipgram model. So basically what that means is we set a window size, and you slide a window across your sentences or your entire corpus, and you have a pivot word, and you have a window going backwards, a window going forwards. For us, if we set our window size equal to 2, right here, and we have the sentence, I love this product, it is perfect. Perhaps we're at the position of product being the pivot word. It would be one of the forward windows, and so it is, and then love and this. So we're taking 2 words before and 2 words after the given pivot word. And this is going to slide across the whole thing. So the next step would be it would be the pivot word, and then is perfect would be the forward window, and product this would be the backward window. So I showed down here what this looks like. You're passing in word pairs into our network. So our X input is going to be product, and then our output would be love because it's inside of this window. And because our window size is 2, and we're doing 2 on each side, there's going to be 4 total. So product love, product this, product it, product is. And just like we just did before, we're going to be turning these things into numbers. So say 4 is the unique number for the sentence. For product, we're going to say that X is 4, 4, 4, 4, and then the Y is 2, 3, 5, 6. And remember that these are unique numbers of the vocabulary. So if they're reused, then you'd reuse the number too. What we need to do next is to actually do this. So we need to take the text and we need to turn it into these numbers. So in order to do this, we're going to use something called the vocabulary processor from tflearn. So that's why you need tflearn. And if you look here, I could try to explain what it does. And basically what it's going to do is it's going to take our sentences and it's going to convert them to these numbers. And these numbers are the unique numbers for that word. So wow, what great stuff turns into 1, 2, 3, 4. So good stuff would be 5, 4, because 5 is now the 5th unique word it's come across in the text. But stuff already exists in the text here, so it's going to reuse it as 4. The other thing that the vocab processor does is it takes in a max sentence length. So if for example, if you give it a 4 and this sentence is four words long, so nothing's going to happen to that. But since this one has 2 words in it, it's going to pad it with zeros. So it's going to put a bunch of zeros at the end here. So 5, 4, 0, 0. And similarly, if it was 3, it would cut these off here. So now this would become 6. But these things would, or rather this would be 4 and this would be 5. But basically that's what's going to happen. But the problem is that with all these zeros, we don't want to end up having these zeros be in our data, because it's going to end up saying, okay, x is 0, and then y is 5, 4, and then 0, 0. So what we're going to do is we're going to cut off all these zeros and effectively make our sentences look like this. And basically we get to use the vocab processor for making all these unique indices, but then we can get rid of those padded zeros because they're kind of annoying. So I already wrote some of this because I want to make sure that I don't mess it up, because there's quite a bit going on and it is a little bit complicated. So I'm going to go through this line by line and explain it. So like I said, we set a max sentence length. So I set it to 100. And then we're going to make the vocab processor. So in order to do that, you just write this here. It's the tflearn.datautils vocabulary processor, and we pass it our max sentence length that we just made up here. So we haven't actually passed the text to it yet. So remember, our text is called text here. And we say data equals list of vocab processor.fit transform text. This line alone, without the list part around it, will return a generator. So we write list and put that around that, and it'll make it a list. And instead of it saying, oh no, this is a generator, you can't do that. So after we do that, we are going to grab our vocab size from this vocabulary processor, which conveniently enough will do that for us. So we call vocab processor dot vocabulary underscore. It's kind of confusing. I'm not sure why they use an underscore, but it's a thing. Somebody wants to explain that one to me, go ahead. In order to do this, we just say length of vocab processor dot vocabulary underscore, and we'll get how big our vocab size is. After that, we're going to take this data here that we grabbed, and we're going to convert the inner lists to Python lists. Because when we do this, we're going to get a list, but all the inner lists, all of these lists here, you know, the 1, 2, 3, and the 4, 5s, these are going to be NumPy lists. And we don't want that for what we're about to do, because we want to pop off all those zeros. So this is the way I did it. I'm sure there's a different way to do it, but this is the way I did it. I converted each one to a list by saying data equals i.toList for I in data. So for every list inside our data, convert it to a list, a Python list. And then we say for every list inside our data, we're going to try to pop off the last one if it equals 0. So pop off last index if it is equal to 0. And if it breaks, then basically what we're going to have is we're going to have an empty list, right? So if it says, oh, you're out of range, it's saying, okay, your list is empty now because you can't grab a last element of an empty list. So if it throws an error there, we're just going to say pass, don't worry about it, and we're going to handle that right here. So we're going to filter the data for none lists, so lists that are empty, and that'll get rid of that, but it'll return a filter object. So we have to convert that again. So convert data to NumPy list after converting filter to Python list. That's what this is saying. So say list of data, so this returns a filter, so list of this, and put that inside of a new NumPy array. So now we have our NumPy array of these indices right here cut off with all those zeros. So we had all these zeros here maybe, and then we cut them all off. So now we have a list of numbers, a list of lists of numbers. So this is when it gets a little bit more tricky. So before we were talking about how there's a window size and pivot words. So for a given window, say we have 2 here, we set our window size to be 2. Our pivot word is going to be 3, and then 1 and 2 are going to be the backwards window, and 4 and 5 is going to be the forward window. So we effectively are going to have we're going to have four data points for each pivot word because the window size is 2. If the window size was 3, it would be 6 because it's whatever the window size is times 2, because you have your backwards window and your forwards window. So what we're doing here first is we're making a list for pivot words. Pivot words, i.e. are inputs, and then target words, i.e. are Y's or outputs. And these are going to be used to store all of them. So our pivot word, so if we look at this one up here first, what we want to end up having for our first 4 entries is, for pivot words, it's going to be 3, 3, 3, 3. And then for target words, it's going to be 1, 2, 4, 5. That's what we would want in our first part of both of those lists. So what we're going to do is we're going to loop through our data. So our data is this shape. So it's num sentences by sentence length. So we're going to loop through all of our sentences and say pivot idx equals data d, so data at that sentence, from window to negative window. And what this is basically saying is that 1 doesn't have a negative window, right? And neither does 2. It only has 1 spot here. We're looking for 2. So the first potential data point that we have is going to be this 3 here, because it has 2 behind it and 2 in front of it. And likewise, you can't do this to 7 because 7 has nothing in front of it. So we're going to, and so the last one we're going to be able to use is 5 because it has 2 in front of it. As soon as we hit 6, there's only 1 spot here, so we can't use that. So what we're going to do is we're going to cut off the leading and the trailing spots that don't have 2 before it, 2 after it. And these are going to be our pivot words. And essentially what we're going to do is we're going to take these and then multiply them by window size times 2. So what our ending pivot words list here is going to look like is it's going to be 3, 3, 3, 3, 4, 4, 4, 4, 4, 4, 5, 5, 5, 5. That's what that would look like. So we set our window size, we loop through these sentences, we cut off those leading and trailing ones. So now we know what our pivot index is, and we're going to look at our data and try to go forward and backward between it. So we're looping through the length of our pivot index. So we're looping through all of these, and we're going to say wherever we are in that list is going to be our pivot word at the current time step. And then we're going to make a targets array to store all of our targets. So you have to get the targets that are before your word, and you have to get the targets that are after your word. So we're going to get the ones that are before it first. So what this is saying is, so at data d, so in our current sentence, we're going to select I to the window size plus I. So if we're at 0, this is 0 to 2, because it's 2 plus 0. So it's 0 to 2 plus window, or to window plus I. So as we move, it's going to slide that window across our data. And similarly, we're going to do it to the positive window, which is just on the other side of our pivot word. So we're going to say I plus window plus 1, because we have to get on the other side of our word, our current pivot word, and say, and we're going to say, okay, go from there to I plus window again plus 1. And this basically this again, but we're just adding another window because we have to go past the pivot word and get 2 spots after that, our window size. I know this is a little bit hard to understand when I'm saying it, and I know it's a little bit tricky to see it written like this, but I really encourage you to go into idle and go into the interactive and play with these lines here and just see what they do, because what they're doing is they're sliding across that window, and once you see it happen, it makes a little bit more sense. So what this is it's our negative target, this is our positive target. So what we're going to do is we're going to take these targets and we're going to append them onto each other. So we'll have the positive and negative targets on top of each other, and then we're going to flatten them, and then we're going to convert them to a Python list. And then after that, we're going to say for every single one of these that we have here, we're going to add these pivot words the amount of times of window size times 2, which is what we did up here where we were saying, oh, I deleted it, but where we were saying 3, 3, 3, 3, 4, 4, 4, 4. You need to have 4 inputs for every pivot word because our window size is set to 2. So we append the current pivot word 4 times, and then we're going to append all the targets that we just grabbed from here. And once you do that, you should have the correct data. And now one thing I did do that I didn't mention is that, delete this later, it says df equals df up to 1,000. And that basically what that's going to do is it's going to allow me to run this a little bit quicker than I would be able to otherwise because the data set is pretty large. So while you're running this and you're playing with it, I would suggest putting something like this so that you can just test it and see what everything's doing. So I'm going to run it real quick. Okay, and it finished running. So again, our final lists are pivot words and target words. So let's look at pivot words up to 10 and target words up to 10. And you can see that these pivot words, again, like I said, should be repeated 4 times because our window size is set to 2. So we have 3, 3, 3, 3, 4, 4, 4, 4, 5, 5, and I'm sure it'd be 5, 5 after that. And you can see that our target words 1, 2, 4, 5. And for the sake of example, it's nice because these are the unique words and they are going to start at 1. So you can see that this is doing exactly what we're trying to do. And now we have our inputs and our targets that we're going to use to input into our neural network, which we're going to make in the next video. So stay tuned.